When there is no chance of the happening of an event, we say that the probability is 0. A is the number of outcomes favorable to the occurrence. A plus B is the number of possible outcomes. If it is denoted by B, then I say that B by A plus B is non-occurrence of the event. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session, I will be having a discussion on probability. What is probability? What is the meaning of probability? What are the different types? So, what are the various concepts involved in probability? All that will be discussed in this session. Now, let us have an understanding of the word probability. See, probability means the likelihood of the happening of an event. We say that the event has one chance. It means that it is bound to happen. So, probability means it is the likelihood of happening of any event. So, an event may happen, so that we call it as probability. When there is no chance of the happening of an event, we say that the probability is 0. So, when there is no chance of the event happening, then we say that probability is 0. For example, when we toss a coin, either we get a head or a tail. So, there is every possibility of getting a head or a tail because of the event. Now, what is the event? Event is the tossing of the coin. So, that event is called as, so either you get head or a tail, so it becomes a result of the event, and that we call it as the probability of getting a head or a tail. So, the probability is 1. Next, the probability of happening of an event is either 1, less than 1, but not more than 1. See, one thing you should remember always, the probability will be 1 and less than 1, but always not more than 1. Then, future events are uncertain. We can identify two types of phenomena in our daily lives. So, we all know that future is uncertain. So, we cannot predict the future. But then in probability, we can identify two types of phenomena in our daily lives. One is the deterministic. Second one is the probabilistic. Now, what do we mean by deterministic and what is probabilistic? So, in deterministic, so everything is predetermined. For example, you take the example of the college timetable. So, the college timetable will be fixed always. So, 100% the classes will go on as per the timetable. So, there will be no change at all, and you can be sure that the timetable will go as per the schedule. So, that is deterministic. It is something which has been determined. Now, second one is probabilistic. Now, what is this probabilistic? So, probability is something which we cannot predict, or something which we cannot say that this such and such an event will happen. For example, when you toss a coin, we will not know whether we get a head or a tail. Or when you toss a dice, so we will not know what face will come up. So, any of the 6 faces may come up. So, that is something which is probabilistic. So, it may rain or it may not rain. It may be a sunny day or it may be a rainy day. So, all these things we cannot predict. So, that all these phenomena we call them as probabilistic. So, those things which are predetermined and which go as per the schedule, they are deterministic, and those things over which we do not have any control, so those things we call it as probabilistic. Next, so in this probabilities, we have various theories of probability and various approaches to these theories. In this, the first approach is the classical approach. Now, let us understand what is this classical approach. So, this approach is suitable for gambling situation. Under this approach, the probability of an event is the ratio of number of favorable outcomes of an event to the number of possible outcomes. So this kind of a classical approach, it is usually favorable for gambling situations. Now suppose there is a gambling going on, so we will not know who will be the winner. So this kind of a probability or a classical approach, it is applicable for gambling situations, and under this approach the probability of an event is the ratio of the numbers of favorable outcomes of an event to the number of possible outcomes. Now, hence the probability of the occurrence of an event E is defined as PE, the ratio of favorable to possible. So, the ratio of favorable events to the ratio of the number of total events. Suppose we have a dice, we toss a dice. So dice has 6 faces, and suppose I tell the next event will have a number with even number. So dice will have a face with even numbers. Now the dice has 1, 2, 3, 4, 5, 6. So there are 6 faces of the dices. So out of this, even numbers will be 2, 4 and 6. So suppose I say that the next I will get an even number. So then the chances of getting an even number are 3. But what are the total number of outcomes? Total number of outcomes is 6. So out of 6 faces of the dices, so 3 faces are favorable to me. So the chances of getting an even number is 0.5. So 6 divided by 3 is 1 by 2. So it is 0.5. So my chances of winning is 0.5. That is half, 50%. I may win or I may not win. So this is the classical approach where the probability of the occurrence of an event equals the ratio of the favorable to possible. So that is favorable. If I get an even number, that is favorable, but it is the ratio between the favorable to the total outcomes. So that is the classical approach. We consider this kind of a probability. Now next, symbolically P equals A by A plus B, where A is the number of outcomes favorable to the occurrence, A plus B is the number of possible outcomes. So as I told you earlier, when I have dice has 6 faces, and out of this suppose I say 3 with even a number coming up. So 3 is favorable to me out of the total 6. Then again the probability of the non-occurrence of an event can be denoted as QE, and it can be measured as B by A plus B. Suppose I say that probability of an event occurring is A, then I can also say that the probability of an event not occurring will be B. So if it is denoted by B, then I say that B by A plus B is non-occurrence of the event. So number of outcomes not favorable to the occurrence of an event. Suppose there are no even numbers coming up at all. So that also we can tell through this probability. So the number of favorable outcomes is A by A plus B. The number of non-occurrence of the event, that we call it as B by A plus B. Now the second approach is the empirical approach. According to this approach, the probability can be done through repetitive experiment, and it can be presented as PE. So, as per the empirical approach, we say that probability can be done through repetitive experiments, and they have given us this formula, that is PE equals A divided by N. So, where A is the expected number of events, A is the next expected number of events, and N is the total number of experiments. So A is the expected number of events and N is the total number of experiments. So one thing we should understand, by repeatedly we do the same experiment, the probability will be stronger or be getting a more accurate probability. Next, we have the axiomatic approach. Now, what is this axiomatic approach? According to this approach, the probability of the occurrence of either two events is the total of the occurrence of each event individually. So this approach is applied when the events are mutually exclusive. So if A and B are mutually exclusive events, then the probability of occurrence of either A or B is P of A union B equals P of A plus probability of B. Now, according to this axiomatic approach, the probability of the occurrence of either two events is the total occurrence of each event individually. So, it is applied when the events are mutually exclusive. So, if A and B are mutually exclusive, then probability of occurrence of A and B is A union B equals probability of A plus probability of B. Now, next, we will learn some fundamental concepts of probability. Now, in this, the first one is random experiment. Now, what do we mean by random experiment? It is an act where the outcome of an event cannot be predicted accurately. So, a random experiment is something where the outcome cannot be predicted accurately. For example, I toss a coin. So, when I toss a coin, it is a random experiment because I will not know whether I'll get a head or a tail. Similarly, if I just select a card from a pack of 52 cards, I will not be able to know what is the number I am getting. So, these are all examples of random experiment. Suppose I cast a dice. So, I will not know what is the number which will turn up. So, these are all random experiments. For example, if we toss a coin, the outcome of tossing cannot be predicted accurately. It may be a head or tail, but both cannot happen simultaneously. So, when we toss a coin, we may get a head or a tail, but then both of them cannot happen simultaneously. So, that we call it as random experiment. Then, next one is the event. Now, what is the meaning of event? The result of random experiment is called an event. When I toss a coin, I get a head or a tail. So, getting a head is an event, getting a tail is also an event because it is the result of the random experiment. Then, next one is mutually exclusive events. Now, what are these mutually exclusive events? So, when both the events cannot happen simultaneously in a single trial, it is called as a mutually exclusive event. So, mutually exclusive means if one event happens, the other event cannot happen. So, they are both mutually exclusive. So, for example, if one coin is tossed, then either head can be up or tail can be up, but both cannot be up in a single trial. For example, the tossing of a coin. So, when we toss a coin, either we get a head or we get a tail, but we cannot get both. So, that is what we call as a mutually exclusive events. So, even when you cast a dice, so either we get any one number, it may be a 6 or a 4 or a 3 or a 2 or a 1. So, all other numbers, they will not occur. So, that is what we call it as a mutually exclusive event. Then, next one is collectively exhaustive event. A set which consists of all possible outcomes is called as a collectively exhaustive events. Now, what do we mean by collective? So, mutually exclusive means, so when one event occurs, other event will not occur. When the head comes, the tail cannot come. When the tail comes, the head cannot come. So, in a collectively exhaustive event, it is a set which contains all possible outcomes. So, that we call it as a collectively exhaustive events. Example, when we toss two coins. So, when we toss two coins, so what are the probable outcomes here? So, we may get head. So, both the coins may fall with head up, or both the coins may fall with tail, or head, tail. So, one head, one tail, or one tail, one head. So, both may happen. So, that we call it as the collective exhaustive events. Collectively exhaustive events means either I get both heads, both tails, or one head, one tail, one tail, one head. So all these together we call it as collectively exhaustive events. Then next one is independent events. When the happening of one event does not affect the happening of the other event, it is called as independent events. So when the happening of one event, suppose when I toss a coin, I get a head, so it will not affect the possibility of the other event not coming. So that we call it as the independent event. Then next one is equally likely events. Now what are these equally likely events? When all the events of the sample space got equal chance of occurrence, they are called as equally likely events. So in the case of tossing a coin, the head and tail are equally likely events. So equally likely events means all the events have equal chance of coming up. Suppose I toss a dice. So when I cast a dice, so all the 6 faces have equal chance of coming up. So that is what we call it as the equally likely events. So when I toss a coin, there are 2 equally likely events. That is, I may get a head or I may get a tail, and both have equal chance of coming up. So we say that they are equally likely events. Then next one is dependent event. Now the occurrence of one event affects the occurrence of other events is called as dependent events. So when I get one event, it affects the other events, so that we call it as the dependent events. Next are complementary events. Now what are complementary events? Non-occurrence of an event are called as complementary events. So if we expect an event A should happen, then the events denoted by A. For example, if we throw a die and expect number 4 should occur, then the other events 1, 2, 3, 5, 6 are complementary events. So in case of complementary events, the non-occurrence of an events are called as complementary events. Suppose I want the number 4 to come in the dice. When I cast a dice, I want the number 4 to come up. So if the number 4 comes up, so all other numbers in the dice, we call it as the complementary events. So they don't come up, so we call it as the complementary events. Then next is the sample space. The set of all possible outcomes is called as the sample space. So the set of all possible events in whenever you have a random experiment. For example, so when I have a pack of cards, so what is the sample space in a pack of cards? In a pack of cards, there are 52 cards. So I may pick any one of the 52 cards. So the sample space is 52. Suppose it is a coin. So what will be the sample space? If it is one coin, it will be 2 events. Suppose it is a dice, then the sample space is 6. So in this way, we should understand what will be the possible outcome and what are the sample spaces for the various kinds of events which we are doing. So with this, we come to the end of this session. Hope you have understood. Thank you.